Okay, so this is section 10.4, and we're picking up where we left off with number 35. So the measure of angle LSR is equal to half the measure of arc LOR, where the measure of arc LOR, that would be 6/8 of the circle. So we have these arcs where there's 1, 2, 3, 4, 5, 6, 7, 8. But we're leaving off these two. So we just want 6 of the 8. So this is equal to 6/8 of the entire 360. Okay, so 6 times 360 divided by 8 will give you 270. And then once again, to find the measure of angle LSR, we're going to substitute in 270 back here. So we want to take half of 270. And our answer is 135 degrees. In number 37, we want to write a 2-column proof of the inscribed angle theorem, the second case of it. The first case has been proved already at the top of page 724. So we'll introduce that proof into this proof as we go. So in step number 1, by the angle addition postulate, we know that the measure of angle ABC is equal to the measure of angle ABD plus the measure of angle DBC. So this entire angle, we can get its measure by adding this angle and this angle together. Now we want to see if we can substitute something in place of these other two, maybe get something else in their place. So the measure of angle ABD we know is half of its intercepted arc, and DBC is half of its intercepted arc. And that's where case 1 of the theorem comes in. So at the top of page 724, case 1 is proved. It says that the measure of an inscribed angle whose side is a diameter is half the measure of the intercepted arc. So since ABD, one of its sides is a diameter, and DBC, one of its sides is a diameter, from that proof we can say that this angle is half of its intercepted arc, and this angle is half of its intercepted arc. From there we're going to use a little substitution. So back on statement 1, in place of ABD, we're going to substitute half of the measure of arc AD. In place of DBC, we're going to substitute half the measure of arc DC. And then we get this new statement. So I take this out, I put this at its place. I take this out, and I put this in its place, and I get this new statement. From there, we can factor out 1/2 out of both of these terms. So I'm left with half times the quantity, measure of AD, plus measure of DC. From there, by arc addition postulate, I know that AD plus DC is equal to AC. So if I add this arc measure and this arc measure, then I better get this arc measure right here. And then by the subtraction property of equality, we can write down what we were trying to prove, that the measure of angle ABC is equal to half the measure of arc AC. So basically I subtracted I meant substitution on this step. So what are we substituting? We're taking half of the measure of arc AC and putting that here. So if I take half of this side of this line, then I have to take half of this side. So what is half of this side equal to? Well, half of the measure of arc AD plus the measure of arc DC is equal to the measure of angle ABC. So I can substitute this in place of this. So I get the measure of angle ABC is equal to half the measure of arc AC. On 39, we want to write a two-column proof for theorem 10.7, which says that if angle FAE and CBD are inscribed and arc EF is congruent to arc DC, then angle FAE and CBD are congruent. So basically what it states is that if you have two inscribed angles that intercept congruent arcs, then those two angles will be congruent. So let's state our given information, everything that we had up here. From that, let's see what we can write down. So FAE is an inscribed angle. So by the inscribed angle theorem, we know that it's half of its intercepted arc, which is EF. So angle FAE is equal to half the measure of arc EF. And I should have put measure back here. So the measure of angle FAE is equal to half the measure of its intercepted arc. Likewise, the measure of angle CBD is half of its intercepted arc, which is CD. That's by the inscribed angle theorem. By definition of congruent arcs, since EF and DC are congruent arcs, then we can say that they have equal measure. So notice the difference in notation there to there. Then we're just going to take half of each side, so we're multiplying each side by 1/2. That's the multiplication property of equality. And then we're going to use some substitution. So what can we substitute in for 1/2 measure of arc EF? Well, back in step 2, half the measure of arc EF is equal to the measure of angle FAE. So we're going to substitute the measure of angle FAE in place of this side, and we get this side. Half of the measure of arc DC, we know that that's equal to the measure of angle CBD. So we're going to substitute the measure of angle CBD in place of this side, and we get this. So now we know that the measure of angle FAE is equal to the measure of angle CBD, and we have one more step by definition of congruent segments, congruent angles. Since the angles have the same measure, we can say that the angles are congruent. And that's it.